Hello everyone. In this video I will be explaining the second type of control chart, which is called as P chart. So in the earlier class we have seen X bar chart and R chart. Those two charts will generally fall under the category of control charts for variables. Now we will see the second category of control charts, which are nothing but P chart, NP chart and 100P chart. Three types of charts will fall under the category of control charts for attributes. So now as far this class is concerned, we will restrict our topic only with P chart. So for plotting the P chart, I have taken a simple example here. So the daily production in the machine shop is 1000 items. These items are inspected as 100 daily for 10 days. So here the major objective of P chart is to concentrate or to focus mainly on the rejections. That is, how many number of defective items are occurred for the number of items inspected for that particular day. So here he has clearly mentioned that 1000 products are manufactured in a day. Out of these 1000 products, they are going to inspect only 100 products daily, and these 100 products per day will be completed for 10 days. So he has given very clearly for 10 days they are going to complete the inspections. And he has given some rejections also along with the date, that is 10 days they are going to inspect, right? So 1 to 10, so daily they are going to inspect 100 into 10, obviously 1000. So for each day they got some rejections. So as I said here, the main focus of this control chart is to concentrate only on the defective items, whether they are defective or non-defective. So when they inspect 100 items on the first day, they got 2 rejections. On the second day, if they inspect, they got 10 rejections, like that. So number of defectives or number of rejections for all the 10 days have recorded here. According to this data, we are going to plot the control chart. So now for the solution is as far as the solution is concerned, there are two types of control charts here. One is constant sample size control chart, second one is variable size control chart. So what is the difference between these two is constant sample size. Because we are inspecting only 100 items per day, so this sort of problem is called as constant sample size. Here the sample size is not varying. Every day we are going to inspect only 100 items, and these 100 items are completed for 10 days to inspect all the 1000 items. Whereas the second category, variable sample size. Variable sample size, as the name itself indicating, the number of items inspected per day will vary. That is, it does not remain same for all the days. So as per this question is concerned, this is called as constant sample size, as they are going to inspect only 100 items, which is fixed for all the 10 days. So this is the first step. First one, we have to see whether it is constant sample size or variable sample size. After that, you need to calculate the fraction defective. As this particular chart is called as P chart, which is also known as fraction defective chart. So the first step is to calculate the fraction defective. So for the definition, I have written here. Generally, fraction defective is represented by P, which is nothing but A by N. What is A here? Number of rejections or number of defective items per day. N represents number of items inspected per day. So for calculation purpose, I have taken a tabular column here. So for all the 10 days, how many number of rejections they got, so I have recorded here 2, 10, 6 up to so on. So here in the question they have given the data, so the same data I have copied here, and number of items are going to inspect are 100, so that remains same for all the 10 days, right? 100 into 10, 1000. So fraction defective, as I said, P generally it is represented by is equal to A upon N, that is number of rejections or number of defectives upon number of items inspected. So for the first day it is 2 upon 100. So fraction defective is 0.02. 10 upon 100 is 0.1. 6 upon 100 is 0.06. 20 upon 100 is 0.2. Similarly, you need to calculate all the fraction defective values in the following fashion. So after completing this, the second step is to calculate the average fraction defective. How to get the average fraction defective? Generally, average fraction defective is represented by P bar, and the formula for P bar is equal to summation A upon summation N. Summation A is adding up all the defective values. Summation N is nothing but all the inspected values. So here summation A is equal to 111, we got it as summation N, however it is 1000. 111 upon 1000 is 0.111. So this P bar or average fraction defective is used for plotting the graph. As I said, one is center line, second one is upper control limit, and second one is lower control limit. So this P bar will be the center line for the chart that you are plotting. And the next step is to calculate the control limits. As I said, to calculate the control limits, one is upper control limit and second one is lower control limit. Because we are plotting for P chart, I have indicated with suffix P. So the formulas for P chart is P bar plus 3 into sigma P bar for UCL and P bar minus 3 into sigma P bar for LCL. So you have a sign change here, whereas sigma P bar indicates standard deviation. So this standard deviation you have to calculate by using this particular formula, root over P bar into 1 minus P bar upon N. So you have with P bar and you also have with N, right? N is nothing but the sample size inspected per day. Next P bar which you have obtained here, 0.111. Substituting all these values, 0.111 into 1 minus 0.111 upon 100, you got the sigma P bar as 0.031. So now you got a standard deviation, and substituting this standard deviation in this particular equations 1 and 2, you get upper control limit and lower control limits. See here I have done already UCL and LCL upon substituting the standard deviation values. So UCL as 0.204, LCL as 0.018. Now after completion of UCL LCL, the next task is to plot the control chart. So you have center line, you have UCL, you also have LCL. Now you can plot the chart easily. For what values we have to plot the chart? We need to plot the chart for all the P values. For all the P values which you have obtained here, right? P values which you have obtained here, for all the values of P, once again I have written here 0.02, 0.1, 0.06, like that. For all the 10 P values which you have obtained, you need to plot the chart. So for this I have taken x-axis and y-axis again. Upon x-axis you have 10 samples or 10 days, and upon y-axis, as I said, you will start with 0 initially and lower control limit, and P bar is a center line, that is which you have calculated. Upper control limit will be above the center line, that is P bar. So P bar, however, you have calculated 0.111. So above that you will be getting UCL which you have calculated here 0.204. LCL is however 0.018 which you have calculated here. So initially it is 0. So for all the values of P which I have written here, first one is 0.02, right? So where does the 0.02 value exist here? So however it is 0.018, right? So it is somehow above this particular LCL, 0.02. The second value is 0.1. So where does 0.1 exist here? The center line is 0.111. So below the center line, somehow below the center line, you will get the second value. Similarly 0.06. So if it is 0.02, so however 0.06 will come above this particular value. Similarly for all the 10 values, you need to plot the points. Joining all these points with the lines will indicate the control chart. Now you have to conclude whether the process, as I said, the major objective of control charts is to see whether the process is in control or out of control. So now looking at this particular chart, we say that the process is in control, as all the sample points of P is lying within the control limits. No sample point is falling beyond the control limits. Therefore, we say that the process is in control. So this is the procedure for finding out or for calculating the control limits, as well as for plotting the control charts. The major thing is you need to remember, for plotting the chart, you should have a center line, you should have a UCL, and you should have LCL, lower control limit. So keeping all these points, if you can compute, you can plot the chart easily. So thank you for watching. Please do subscribe the channel. Thank you.